Yeah. Now, well, I wonder, is it a benefit to have the earphones? Don't they have voice activation? I wonder if that would be better. I'm just
I'm not
asking.
sure, but I have to use headphones regardless. Otherwise, other people can hear their own voice playing out of my speakers back at them.
Yeah.
And it causes an echo that drives people crazy. So whenever I'm in a voice
I
call with
don't.
somebody, I just put in headphones.
Well, I don't have any problem with y'all leaving y'all's microphones on as long as you don't have no blame dog barking in the background. That's about the only thing that drive me bananas. So okay, I've got everything on. Y'all should be able to see my screen. Um, I did get a couple of questions from y'all. I know Mr. O'Quinn sent one, and I think I got 3 questions. Okay, you want the good news or the bad news?
Rip it off like a Band-Aid.
What? Okay, let's take bad news. The bad news is I'm having to research them to figure out how to answer them. The second thing is because one of them is real simple, but the way they've got the thing, you just got to take the slope at each point and subtract it from each other, which is nothing. And this is the good news. The good news is there's no way in Hades I'm going to put those questions on the test because to me they're useless. Okay, so I will go over those probably either Wednesday or Thursday. Mr. O'Quinn, is that okay with you? I don't think it's going to stop the world from revolving. I think you sent one. And I want to say Miss Patel sent one. I can't remember, but is that going to stop you from, doing your thing?
Out for Dawn. It was one of those doesn't have the help options
Yeah.
available.
Okay. So I'm having to research one of them because I have no earthly idea what they want. I think they're wanting to plug the difference quotient, use the difference quotient. I think that was yours, Mr. O'Quinn. And the other one somebody sent was subtracting the slopes, which to me is fine, but it has nothing to do with what we're doing. So, in other words, I'm going to go ahead and we're going to plow on because what I want you to be able to do, I want you to be able to do the power rule, the quotient rule, the product rule, chain rule, and trigonometric functions, basic. I want you to be able to do those like playing the piano fluently.
Backwards and forwards.
Exactly. That's what I want you to be able to do. So that's all I care about, and that's all I'm going to test you on. All right, so let's get started. Let's start with a basic power rule from last week. And let's go with f of x is equal to, where's my, I'm trying to turn everything off for you. There we go. F of x is equal to 4 over x squared minus x squared over 4. Now, the reason I'm giving you this one is because you have to rewrite it before you do anything. Okay? And, however you want to rewrite it is fine with me. I don't really care. But using the inverse rule or the inverse power rule, the inverse rule, you can actually, rewrite it and say f of x is equal to 4x to the negative 2 minus 1/4 x squared. Okay, now you don't have to change this to a negative 2. You don't have to do that. You could say 4 over 1 x squared minus 1/4 x squared. Does everybody understand that? Okay, you don't have to do that. I'm just doing it to kind of make it simple because I'm going to use the power rule like that. So I'm going to go over here, and that's going to give me negative 2 times 4 x to the negative 2 minus 1 minus 2 times 1/4 x to the 2 minus 1. And that's going to give me negative 8 x to the negative 3 minus 1/2 x to the 1. And that's going to give me negative 8 over x cubed minus x over 2. That's probably the way I would leave it. I really don't see any other way to write it. Is this a test question? Oh, hell yeah. Because the first thing it tells you to do is what? Rewrite, if needed. Okay? You can bet your bottom dollar you're going to see, on the power rule, the very basic, you're going to see fractions and you're going to see radicals. Capiche? One more. And this is just a rehash of power rule. So I know most of y'all worked on homework all weekend and you didn't, lounge around and not do anything. Right?
Just because you don't see me logging into a particular assignment doesn't mean I wasn't working on that subject all weekend.
Oh, I know. A lot of people print out theirs. I wasn't picking on y'all. I wasn't spying on y'all. There you go. What is this called? This is called a nested problem. Why is it called a nested problem? Because you got a problem inside a problem. So these are two good. Test questions. So this is going to be f of x is equal to x to the 1/2 raised to the what? 1/2. Radicals and calculus do not mix as far as basics. Okay, we're not talking about trig, we're not talking about antiderivatives. We're talking about the basics. Up to the chain rule is the basics. So that's going to be using the power rule, x to the what? F of x is equal to x to the 1/4. And we've done algebra. The only calculus we got now is 1/4 x to the 1/4 minus 4/4, which is equal to 1/4 x to the negative 3/4. Now, if you wanted to change that and make that 1/4x to the 3/4, that's fine. If you want to make that 1/4 exponent over index would be the 4th root of x to the 3rd, you could do that. I'm not going to worry too much about that. And one more, just for giggles, just to see if y'all paying attention. F of x is equal to 7x plus 3x squared over 5 square root of x. Somebody tell me the first thing to do.
Rewrite
the radical. Good. 7x plus 3x squared over 5x to the 1/2. Okay, now I would take that negative 1/2, 5. I mean, you can't do the 5, but the x to the 1/2, I would take that upstairs. That's what I would do. You don't have to. Go ahead and finish it out. So if you brought the x to the 1/2 up, that's going to give you x to the 1/2 times 7x plus 3x squared all over 5. And you can make that 5 after you do this. You can do 7x to the 2 halves plus 1 half using your exponential laws, plus 3x to the 4 halves plus 1 half over 5 here and 5 there. And that's going to be equal to, and you can put 7/5 right here if you want to, x to the 3 halves plus 3/5 x to the 5 halves. And guess what? We haven't even done what? What have we not even done yet? I'll give you a hint. It starts with a C.
Chain rule?
We haven't even done the calculus yet. Now we're doing the calculus. 3 halves times 7/5 x to the 3 halves minus 2 halves. But most of y'all gave up on this one a long time ago. Why? 3/5 times 5 halves x to the 5 halves minus 2 halves. And this is nothing but the power rule. So 3, that's 21/10 x to the what? 1 half plus 5's cancel. I'm going to leave it 3/10. Why am I going to leave it 3/10? Well, just in case we can factor something out later, I'm going to leave it as, I'm sorry, 15/10. I don't know what I'm thinking of. There we go. 15/10 because of the common denominator. X to the what? 3 halves. I'm going to stop there because you could do all kinds of things here. You could put everything over 10. You could put the x's in radicals. And then you could simplify everything. So there's 2 or 3 different variations of this answer. So again, we did that problem, and most of it was nothing but exponential rules. Most of it was exponential rules. Only calculus is basically right here. They say that Tri-County is going to open up for the fall for back to regular classes.
I would not start that conversation if I were you.
Why is that? I'm going to try to stay home. I ain't going to wear no damn mask. They're going to go away and fire my ass.
That's because you can. What about me? I have to go back to Clemson with a million idiots and try to survive and not die.
Yeah, that's true. I feel for you there because you do, because we only got a small amount of idiots at Tri-County. You got a larger amount at Clemson. All right, let's go with the product rule. Let's go with something simple so you won't get discouraged. Some of y'all are already discouraged because we made you do fractions. X plus 1 times x squared minus 3. All right, go to it. I'm going to give y'all a minute. If you can't do it, then we all know what that means. You suck. And you should have joined the Air Force. At least they got maids that clean up for you. I'll never forget, we pulled out of Norton Air Force Base right at the beginning of the Gulf War. It was November. Let's see, what comes for November? October. And we were sitting there. And in Marine Corps, you just vegetate until you leave. So we were just sleeping outside up against the hangar, and we were watching. And it was about 6 o'clock the next morning, and we watched. And the Air Force got up and left their barracks, and here comes a little maid with a little cart, like at the day's end. We're like, really? Okay, I'll shut up.
I was told if they had to live in the same conditions as the Army or the Marines, they got substandard living pay.
Oh my God. I wouldn't doubt it. But, you know, with the Marine Corps, if you're able to swing with the wing, you got it made. Those pilots, they got the best food, they got the best mess hall, they got the best everything.
Patel had a question in chat.
Okay, okay, I can't see it. Hold on. I've got y'all in attendance mode. Let me change it to chat. I wish they could do both. So when can you use the power, exponential, quotient, and product rule on the test? Well, it's kind of like this. Do y'all remember the exponential laws that you had in algebra?
Yeah.
Is there one certain way to do the exponential laws?
God.
No. So you don't have to do, there's different ways you could do the, now the chain rule, there's only one way to do the chain rule. We ain't got that. We're going to get to that today, hopefully. But, you know, here, you could, is anybody done the algebra first? Here, you have a choice.
Yeah, I did the algebra first.
You can do the algebra first and use our good friend, the FOIL method. Pronounce it however you'd like. And, or the second option is to use the product rule. Now, the product rule is going to enclose the power rule, because the power rule you're going to have to do with each term. So the power rule is going to be in your product rule. All right, so, and the power rule is going to be here inside your FOIL, because you're going to do each term. So with that being said, let's divide it into two sides. And we're going to do the algebra first. X times x squared is x to the third minus 3x plus x squared minus 3. Now I just did that. Now I'm going to do the power rule with each term. And how do I do that with each term? That's using the sum / difference rule. Remember what I told you? I think that's number 2 and 3 on your basic laws. Go to your sheet that has the basic laws on it, and it'll say power rule or constant rule, power rule, then it'll say sum and difference rule. The sum and difference rule is just a sophisticated way of saying take the derivative of each term. So I've got 4 terms here, and I'm going to use the power rule. 3 times 1, x to the 3 minus 1. That's a 1 right there. Minus 1 times 3, x to the 1 minus 1. Plus 2 times 1, x to the 2 minus 1. And that's x to the 0, because I always want to follow my basics. 0 times 3, x to the 0 minus 1. And of course, that's 0 times 3. That's going to do what? That's going to cancel. And you're left with 3x to the second minus 3x to the what? 0 plus 2x to the first. Now I go and take out everything I don't need. 3x squared, I need all of that. I don't need the x to the 0, that's 3. I don't need the x to the first, that's just 2x. And now you just need to put it in order. Now I'm going to do the product rule. First times the derivative of the second. I'm going to put a little prime up here. It means I'm going to take the derivative of that. Plus the second times the derivative of the first. There you go. You got it. And he also smoked 3 packs of Marlboro Red. There you go. Now you're getting it. All right, so x plus 1. Take my blue pen, that's blue, and that's going to be 2x. Now that's blue. See there? That's not that color right there. That's lavender. I don't know what the heck's going on. It's a conspiracy. Plus,
Watch out for the Russians.
x squared is the Russians. And then what is the derivative of x? And now you're just back to algebra. So distribute that 2x. And that's going to give us 2x times x plus 1 times 2x plus 1 times x squared minus 3 times 1. Now again, I'm writing everything out because that's the way I do it. I'm not here teaching the people that can cure cancer.
That marker color is bugging me. This is
No.
some blue and gold, or is the dress blue and gold or black and something else mess?
I'm sorry. 2x squared plus 2x plus, that's not right. It's not supposed to be x squared.
It is.
Hold on. Oh yeah, we're gonna combine like terms. Sorry. Plus 1x squared minus 3. And these two is going to be 3x squared plus 2x minus 3. Look there. It is what? A miracle. That's 2 ways to do it. So hopefully that'll help you, Miss Patel. And it'll help you when we get into the quotient rule and the chain rule, because you'll be able to see. And it's just like I told you before, how many of you play a musical instrument? There's different ways to hold your hands with how do you know how to hold your hands? Do you know it the first day that you play the musical instrument? Or do you know it after 10 or 15,000 tries? You know it after you practice. I know some of y'all don't like to hear that. Instant what? What do you want? Instant what? Okay, that's okay. I won't say anything. Let's try the quotient rule. F of x is equal to 3x squared plus 5x divided by square root of 5. Now, do you have to use the quotient rule here? Yes or no?
No.
No. Remember that problem we did a while ago? I picked it out for a reason. Hold on, let me find it. There it is. Did I do that one by the quotient rule? No. I brought it upstairs. I rewrote the radical. Is there a law against that? Not unless the directions what?
Tell you otherwise.
If the directions say use the quotient rule, then you're going to have to use the quotient rule. How will they know? Well, they'll ask you certain questions during the process to see if you're using the quotient rule. And yes, I do put those on the test. Okay. All right. So what is the quotient rule is denominator times numerator prime minus the numerator times the denominator prime over Denominator what? Squared. Now that's Dr. Hardin's way of doing it. Denominator times numerator prime minus numerator times the denominator prime over the denominator squared. Can anybody tell me where they think the culprit is to make you screw this up? Can anybody tell me where they think it is?
Square root of 5.
That negative.
Nope.
or
That
minus.
negative. Thank you. Right here. I want everybody to take your daggum highlighter, and I want you to highlight that negative because that's going to ruin some of y'all's day on the test. I always put brackets, whatever I have right here, I always put brackets around it so that it will remind me to use that negative. And some of y'all won't because you already know everything, and you're going to cry when you get 3 problems wrong on the test because of that negative. So here we go. Again, I'm going to use the green with a prime. I'll do this. Hold on. I'm going to use the green with a prime. And because I don't want to hurt Miss Sterling's eyes, I will do away with the blue. And I will go around the brackets here with a red because that is very important. So let's do it. Denominator, square root of 5, times numerator prime, minus, I'm just going to use the red for everything, the numerator times the denominator prime. Well, I'm going to rewrite that denominator as 5 to the 1/2. Everybody with me?
Mhm.
Now, it's a nice thing, and I'll tell you why that's very nice in just a minute. Oops, I was supposed to write that in green. 5 to the 1/2. All over, what is the square root of 5 squared?
5.
Well, I'm going to write it like this so everybody knows I'm plugging it in. Can anybody tell me what happens to the second part of this problem?
Goes to 0.
Say again?
Goes to 0.
Goes to 0 because the derivative of a constant is what?
0.
And 0 times anything. Does that happen a lot? Yes, sometimes it does, but sometimes it doesn't. Now we just go through and we can change this to 1/2. So I'm going to change it to 1/2, and then I'm going to change that to its, I'm going to use that yellow. That'll show up. I don't know if it'll show up or not. No, I'm going to use the peach. And of course, I dropped the black. I got spider bit on my foot. I think I was baling hay yesterday, and it is hurting bad. I know, y'all don't care. 5 to the 1/2 times, and I'm going to take the peach, and I'm going to take the derivative of 3x squared, which is 6x plus what? 5 all over 5. And now you can just simplify it. 5, that'd be 30x to the 1/2 plus 2/2 plus 25 1/2 plus 0 x to the 1/2 plus 0, right? Yeah. Over 5. And that's going to give us 30 x to the 3/2 plus 25x to the 1/2 over 5, and I'm going to stop it there. You can take out the 5, factor out of 5. You could factor out of 5x to the 1/2. I really don't care all about that. I don't care. This is pretty much your first answer, and you can extrapolate off of that answer depending on what you get on the homework. And that's how you do the quotient rule. Now, of course, I'm not speeding through. I'm just wanting to go ahead because I do know that there's some of you in here that know how to do the quotient rule, and I'm trying to get to the chain rule so that way for the next couple of days, we can work on all of them. Does everybody understand that? That's what I'm trying to do. So I'm going to look at my clock. Okay, we've got time to do another quotient rule. I'm going to put this one up in the top left-hand corner, and I'm going to write small because it may be a long problem. Anything to discourage y'all. F of x is equal to 5x squared minus 3 times x squared minus 2 over x squared plus 2. Now we got a problem. Somebody tell me what a problem is. We got the product rule on top. So when we take the numerator, prime, we're going to have to do what? Product rule for the numerator. Or you could just skip this problem because it's too much to do. So first, our denominator.
I was just going to give up and quit, so you're kind of killing my Tuesday night plans.
It's the same thing. So, denominator times numerator prime, and I'm going to put this in brackets. 5x squared minus 3 times x squared minus 2. Minus the numerator, put this in red, the numerator is 5x squared minus 3 times x squared minus 2 times the denominator squared, denominator prime, all over denominator squared, which we do not really concern ourselves with the denominator because what's going to happen, something may do what later on? Something may cancel. So if you're sitting there going, oh, well, I need to do shortcut. No, you don't need to worry about the x plus 2. Worrying about the x plus 2 is worried about what you're wearing when you're running out of a building when there's a bomb fixing to go off. Okay? Worried about this x plus 2, you worry about it at the end of the problem, and the only thing you need to do is see if it'll cancel with something. You need to put your focus on the numerator. Okay?
Priority 1 message coming in on secured channel.
Somebody is blowing my phone up. Go ahead and start on it. I told my son I was going to get him a four-wheeler. And he's blowing my phone up. So I'll put the first one down. That's x squared plus 2. There you go. X squared plus 2. And I'm going to take the peach, and I'm going to take the green and the peach, and I'm going to do the derivative of the product rule here. So first times the derivative of the second plus the second times the derivative of the first. Minus, and that's going to be in red. I better go down here. Excuse me. And that's going to be 5x, the 5x, blah, 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 all that. 5x squared minus 3 times x squared minus 2 times, in peach, 2x. And I'm just going to write down here, I'm going to put denominator squared. I really don't care about that. Now, have we done the calculus? Yes, we've done the calculus. We got one little calculus here and one little calculus here to do, and the rest is 100% what?
Algebra.
Algebra.
Yeah.
Now y'all see why y'all suck at calculus. It's somebody else's fault. It's not your fault. Blame it on Russia. X squared plus 2. And I'm still going to write in green because I'm still trying to. That's 5x minus 3. And I'm going to write in another color because now I'm taking the derivative. So I'm going to write in this orange. What is the derivative of x squared, people?
2x.
2x. Plus x squared minus 2. The derivative of 5x minus 3 is
5.
5. That's that. Minus brackets. And we've already taken the derivative here. The only thing we need to do maybe is use the FOIL method. Pronounce it however you'd like. That's going to be, let me just use black here. 5x to the 4th minus 10x squared minus 3x squared plus what? 6? Be careful because sometimes I will say 5 times 2x. Now, should you go ahead and distribute everything? Yes, because you might see something do what? You might see some canceling going on. Of course, some of y'all have already quit. Equals x squared plus 2. Time for my brackets. 2x times 5x is 10 what? X squared minus 6x plus 5x squared minus 10 minus, I'm going to go ahead and, no, I'm not. I'm going to wait. And that's going to be 10x to the 5th. Y'all help me out here. Minus 20x to the 3rd. Be a minus 6x to the 3rd plus 12x. Y'all check me. I know you can simply, I don't really care about that right now. Right now, all I'm caring about is the signs.
Everything looks good.
Okay, so we're going to go over to the next sheet of paper. And now you're going to have to do, I'd simplify as much as I can right here. Unless you just like whips and chains. If you like that, do a 4-term polynomial distributive law with a binomial, that's fine. But I'd like to drop this down maybe to a trinomial, if I can. So I'm going to fold the paper. Now, I try not to give y'all real complicated problems like this, but you need to be aware that the quotient rule can be nested real easy. Okay? It can be nested real easy. So here we go. I'm going to change this. So I'm going to take another color. We'll go with this fluorescent pink. And I'm going to take 10x squared and 5x squared. And I'm going to combine those two. And that's going to give me x squared plus 2 times 15x squared minus 6x minus 10. Now I'm ready to distribute, but if you want to go ahead and put these two together, you can. So let's go ahead and do that and leave it in red. So 10x to the 5th minus 26x to the 3rd plus 12x, and all that over the denominator squared. Now we're going to distribute this this binomial, and that's going to give us 15x to the 4th minus 6x to the 3rd minus 10x squared plus 30x squared plus or minus 12x minus 20. Y'all check me. And I'm going to distribute that negative, and that's going to give me negative 10x to the 5th plus 26x cubed minus 12x. And all that over d squared. So y'all check for careless mistakes for me. Now I do know that I've got a 15x to the 4th. There's nothing I can do about that. So I'm just going to bring it down. 15x to the 4th. We got a couple of cubes. So 26 minus 6 is 20x cubed plus 20x cubed. Minus 10 plus 30 is 20x cubed. It was 20x squared. Any other x squareds? Plus 20x squared. Darn, we couldn't even get the minus 12s to cancel. Plus be minus 10x to the 5th. Y'all check me. Again, I'm not worried about it because I don't think you're going to be able to cancel anything. I'm going to put
Should
it
be
in order.
minus 20.
Where?
Minus 20. You said minus 12 here. But...
There we go. Okay, so that's going to be negative 10x to the 5th plus 15x to the 4th plus 20x to the 3rd plus 20x squared minus 24x. Is it minus 20? All over d squared, which is going to be x squared plus 2 raised to the second power. Now, you can't even factor out an x, so I think that's pretty much it. Sometimes you can get these to cancel, but the reason I don't think it's canceling, we've got to the 5th power. There's no way that you're going to get a lot of those to cancel. If you've got it up to the 5th power, I doubt very seriously you're going to get anything to cancel. Okay, now don't worry. That is a 8 or a 9 on the quotient rule, okay? And we're going to spend the next couple of days doing these problems over and over and over. Now the chain rule. Now the chain rule is very important. The chain rule is what gets you out of a lot of work. But it also is kind of the most complicated. Okay? And basically, I don't do what they do. Like I don't do anything that they do on that sheet. I do it differently. What I tell students to do is use the power rule plus take the derivative of what's inside. Now, if you've had a good calculus teacher before, that's how they say it. What's inside? What's inside is a term that's used with the chain rule. Okay? Now, if you have one of those math geeks that go, well, you need to take f prime of g of x and do this and do, well, that's not. Most of the time, when you have a calculus teacher that tries to help students learn calculus, they're going to use that term. What's inside? How many of you have heard that before? Let's see the hand thing again.
I don't know how to do the hand thing on my phone, but Dr. Bender taught me that.
It's on the bar. Oh, on your phone. Okay.
Yeah, I'm on the phone, so
Yeah.
I just.
So
I'm
let's
just
see
gonna-
some hands. How many of you have heard of what's inside? How many of you have heard of that before? I have to switch over to it. It's not switching. I guess nobody's used it, or it's not switching, one of the two. Show participants. It's not switching over. Okay. I can't see you, so I don't know if you're doing it or not. Why isn't it showing participants? Lower my hand. Okay, my picture and my sound isn't freezing up, is it?
No.
Okay, just my hand, I can't see y'all. Okay, Miss Gobati has seen it before. I don't know why it's taking so long. Okay, I'm not going to worry about it. I can't see your hands for some reason. Let me go back to chat. Maybe I can switch over to that. No, it's not letting me switch. Okay. All right, so here is the chain rule. Here's an example of the chain rule. And usually when you see those parentheses, and I'm going to do those in blue. When you see a set of parentheses, chances are you're going to use the chain rule. 10x to the 5th plus 40x cubed. Why? Did you get something else to cancel, Mr. O'Quinn? Hello, Mr. O'Quinn.
Yeah, sorry. Yeah. I did the algebra first. I just came to a completely different answer, and I double checked it just a minute ago. And
Well, we might have a mistake in there. That's a long problem. I didn't know that problem was going to be that long. I didn't really. That's my fault. We needed to
He
build
tried,
it.
but he'll quit.
Yeah, I know, but we didn't quit though. Here's a good chain rule. F of x is equal to the sine of 2x. The first thing you do when you see sine of 2x or sine of 4x, you take that handy dandy marker and you put parentheses around that 2x because you got to use the chain rule. Same thing with e to the x. F of x is equal to e to the negative 2x. First thing you do is you put parentheses around that 2x. F of x is equal to 2 times x minus 3 to the second power. Well, you don't have to put parentheses here because what? You have parentheses. Everybody see that? Same thing with the square root. Okay. What are you doing? Okay. Here is the parentheses. Now make that a 2x. Make this a 2x. And make this a 2x because it doesn't work. It doesn't show you enough when you have a 1 there. What is the derivative of the sign?
Cosine.
Thank you. So the first thing I'm going to do is I'm going to say cosine of 2x. Am I done? No. Because with the chain rule, you have to take the derivative of what's inside. So what is the derivative of 2x?
2.
2. So you take that 2 and you put it out front right here. That's the chain rule. What about this one right here? Well, we know that the derivative of e to the x is e to the x. So e to the negative 2x would be e to the negative 2x. But you have to remember that I won't take the derivative with green. E to the negative 2x. Well, what's the derivative of negative 2x? Negative 2, Hubert. That's the chain rule. Okay, here we got to use the power rule. 2 times 2, 2x minus 3 to the 2 minus 1. And then what's the derivative of 2x minus 3? 2. So that's going to be, final answer here is 8, 2x minus 3 to the first power, or 16x minus 24, or 8 times 2x minus 3. I really don't care about that. First thing here, rewrite it. 2x minus 3 raised to the 1/2 power. 1/2, 2x minus 3 to the 1/2 minus 1/2. And then what is the derivative of 2x minus 3? 2. And of course that goes out. And you're left with 2x minus 3 to the 0 power, which is what? 1. Now, I want you to, and I don't know why it's not going back over to the, there it is. Give me hands, or give me a 1 through a 5. Let me go back to the, give me a 1 through a 10 on how much you remember with the chain rule. 1 being, don't remember it too well. You know, y'all are gifted and talented. First time seeing it. Good. I knew I've had a couple. There's another first time. Okay. Now, Mr. O'Quinn, have you had pre-cal before?
No.
Okay. And
Haven't
Mr.
had
Childers,
since
have
2010.
you had pre-cal before?
Yes, sir, I have.
Just don't remember it too well, huh?
No, sir.
Okay. All right, well, let's do it. Let's do chain rule. I'm going to start y'all off real simple because I want to discourage you later. X squared f of x is equal to x squared minus 1 to the 10th power. All right, go to it. So that 10 is going to come out front. That's going to be 10 times x squared minus 1 to the 10, and then minus what? Minus 1. And then what is the derivative of x squared minus 1?
X.
2x. And now all you have to do is simplify it. And your answer is 20x times x squared minus 1 to the 9th power. Now, this is not going to be a problem for y'all. Where is it going to be a problem? When they nest it in another problem.
What is he reviewing now?
I'm sorry, say again? What did she say?
Sounded like a small child in the background.
Speak up if that was a question. So let's do a nerd. And I know, let's see what time it is before y'all start to self-combust. I got about 5 minutes. F of x is equal to the 4th root of 9 minus x. All right, take a minute. And then I'm going to write down a problem that you will see on the test, and you can try that for, you know, a little bit of pre-homework. I don't know. Can somebody tell me, if you're looking at the homework, what section is the product rule and quotient rule? Is 3.3 or 3.4?
3.3.
Okay. So 3.3. So that means the chain rule is 3.4.
No, it switches to trigonometric derivatives of trigonometric.
Okay, I'm not worried about that, because as long as you can do the basic trig functions, I don't really care about that. We're going to get to the chain rule with the trig. I'm not worried about that. And people, a lot of you say, why are you doing trig? Why are you doing trig? Because trig is not the most important thing in Calc 1. You being able to play Beethoven's Fifth with antiderivatives and derivatives, that's 90% of Calc 1. The trig functions, if you learn those, great. That's great. But you have got to be able to play fluently the derivatives and the antiderivatives so you have a chance in Calc 2. So 9 minus x. So you can have a teacher that says, you know how to do this. And that's going to be 4. Say again?
I was saying the outline doesn't have it until 3.7.
Okay. 4 minus 1. And then what is the derivative of 9 minus x? Oh, Lord. What would that -1 do to your answers on a test? Screw you up. So please don't let it screw you up. The answer is -4. 9 minus x to the what? Now, could you write that differently? Yes, I'm not worried about that. You could write it with a radical. You can't move the 4 downstairs. A lot of y'all think y'all can do this. 1 over -4. Y'all think y'all can do this. You can't do that. You can't move a negative number up top. If you could, you never have below balance at your checkbook, at your bank. You can't just make a negative a positive by moving it up. You can do that with an exponent, but you can't do it with a number. Everybody'd be have enough money at the bank then. I would just move it up.
All right, I missed where that exponent became 4.
Where?
Shouldn't it be 1 over 4?
I suck. Yes, you're right. 1/4 minus, go ahead and say it, Miss Sterling. I suck. There we go. And that's 3/4. How about that? Is that better?
Much.
Okay. Now, you can take that downstairs and say -4 over 9 minus x to the -3/4. Sorry. And you can change that to a radical. That would be the 4th root of x. That'd be a positive, sorry. The 4th root of x of 9 minus x to the 3rd power. Now I'm going to give you a problem to work on, and I want you to tell me how to start it, because you need to write down how to start it, because it's a nested problem. H of x is equal to the square root of x minus 4 to the 3rd power times the square root of x plus 4 to the 5th power. Now, what's the first thing you'd probably do? You'd forget the algebra, because if you're going to take a 3rd term polynomial and multiply it by a 5th term polynomial, you might as well get you a 6-foot whiteboard, and you might have enough room. So you can forget the algebra. So what are you going to do first? You're going to rewrite that radical with x to the 1/2 minus 4 to the 3rd, x to the 1/2 plus 4 to the 5th. And now what rule? Because since this is a multiplication symbol, what rule are we going to use with the chain rule? Product. So go over to the right-hand side over here and say product with chain. That's a good test question. Question on right complaint. Okay, let me turn off the recording and the presentation. And you should not be able to see my screen now.
We cannot.
Okay. And let me pull up the handy dandy attendance, and it